The last lesson, we learned how to solve linear systems by the substitution method. Now we're going to learn how to solve the systems by what's called the elimination method. Most students like this one the best, but we have to know all of them, how to graph, substitution, and this method. So what are our steps? We want to line up all the variables, constant and the equal sign. We need to decide which variable to eliminate. You get to make some decisions. Then sometimes we're going to have to multiply the equations to make the coefficients opposite values. The reason why we need them to be equal but opposite is so when we add them together, they will be eliminated. So the next step, we would add the equations where you would eliminate a variable and we would solve for the remaining variable. Then we have to substitute the solved value into one of the original equations and then write your answer as an ordered pair. Now I know that looks like a lot of steps, but most of your work, it's not going to involve all of those steps. Let's just see how it goes. On number 1, if you notice, the variables are lined up as best I could when I was typing it, and we want to decide which variable to eliminate. Well, let's just look. We have a positive 1x and a negative 1x. Well, we need to make them opposite values, and that one's already done for us. So I'm going to choose to eliminate the x's because they're already a 1 and a negative 1, those opposite values. So I'm just going to take these two equations and add them together, and we're going to add them vertically. X minus x is 0. I've eliminated x. Negative 4y and negative 2y is negative 6y equals negative 20 plus 2 is negative 18. Then divide by negative 6, and poof, we've got already one variable. Now remember, we have to have an ordered pair. We're solving for x and y. Where do these lines intersect? So I need to put 3 back into one of the original equations. It doesn't matter which one. I think I'll use the second one just because the numbers look smaller. So I have negative x minus 2 times y, which I now know is 3. So I have negative x minus 6 equals to 2. Negative x, I'm going to add 6 and get 8. Divide by negative 1 and I get negative 8. So my answer is negative 8, 3. That's my ordered pair. Can I check that? Yes, I can. I would put negative 8 in for x and positive 3 in for y, and see, that does get me negative 20. And again, I would have to put it into both equations to make sure it works in both, and sure enough, it does. Now, on the next one, you can see that my letters are not lined up. So I need my x's. I like my x's, and then my y's, and then my equal sign, and then my number. Alright, so on this one, I'm going to bring the 2x to the other side by making it positive. Y is already positive. When I do that, that leaves me an 11. On the next equation, I'm going to leave the 2x, move the 3y, and it becomes positive, equal 41. Now they're all nice and lined up. Which letter would be easiest to eliminate? The x's. And that is because they are already opposite values. So I add these together, and that's 0. Remember, that's 1y plus 3y, that's 4y. And 11 plus 41 is 52. So if I divide both sides by 4, I get 13. Now remember, an ordered pair, so I have to go back and get x. So I can choose either equation, this one or this one, to get x. I think I'll choose that one just because the numbers look a little bit smaller. So I have y, which is 13, equals negative 2x plus 11. So if I subtract 11, I get 2 equals negative 2x. If I divide by negative 2, I'm going to get x is equal to negative 1. So my ordered pair, x and then y, that is my answer. And again, I could come back and check it by plugging in negative 1 for x. Sure enough, that would be 2 plus 11 is 13. And then I could also put in 13 for y. 3 times 13 is 39. 41 minus 39 is 2. And sure enough, if I put in a negative 1 for x, that would be 2. So that does check. Now, these next ones, well, number 3, it's all lined up, but if I just add them, nothing's going to be eliminated because I don't have equal and opposite values. So we can choose. We could get rid of the x's, but we'd have to multiply something to get them equal. That's where you're kind of looking for a common multiple, very much like a common denominator. So I could multiply this equation by negative 2, and that would make that negative 10, which would be the opposite of positive 10. So that's one choice. My other choice would be to look at the y's and say, well, I have a 3 and a 1. The common multiple is 3. If this is negative 3, I would have to multiply that by negative 3 because negative 3 times positive 1, negative 3 times negative 1 would be positive 3, and again I would have opposite values. Both of them seem to be about the same amount of work. What do we want to do? I think I'm going to do the second option. So I'm going to keep the first equation as is, and here is the biggest mistake most students make. They forget to multiply everything, the whole equation, by whatever you need to multiply by. So everything gets multiplied by negative 3. So that's negative 30x, that's positive 3y, and that's negative 3. Check that arithmetic. Do I now have opposite but equal numbers? And that's really not right. They're not equal. Their absolute values equal, but they're opposite, and when I add them, they get to be 0. So again, I'm adding these equations. So I have negative 25x, that's 0, equals negative 5. So I have to divide by negative 25. Negative over negative is a positive. So yeah, I got fractions. Am I done? No, I have to get y. So which one do you want to plug in for x? The top one or the bottom one? I think I'm going to choose the top one. I don't know why. So 5 times x minus 3y equals negative 2. Well, that's not so bad because those reduce. Multiply, that's 1 minus 3y equals negative 2. Subtract 1, and then when I divide by negative 3, I'm going to get positive 1. So my answer is my ordered pair, x is 1/5 and y is 1. So that problem we had to do a little more work to get those opposite values.